Bismillahirrahmanirrahim. Assalamu alaikum. Today I welcome you Symbolic Math Toolbox in MATLAB, the video lecture 11. So today we are going to try to calculate Fourier Transform in MATLAB using Symbolic Math Toolbox. So we perform 3 examples and try to get an idea how to solve Fourier Transform equations in MATLAB using Symbolic Toolbox. So let's go to the formula of Fourier Transform. That is x of omega is equal to integral minus infinity to infinity x of t ej omega t dt. This is the formula of Fourier Transform. And today in this video we try to solve 2 examples of Fourier Transform, and one is for the inverse Fourier Transform. So let's go to the first example. We have an example where x of t is equal to e raised to minus 2t. Let me have a highlighter. So that is basically integral minus infinity to infinity, and that is our signal x of t e raised to power minus t over 2 u of t. That is our signal e raised to power minus omega t dt. That is so because of u of t, this integral limits change from instead of minus infinity to infinity, now we have 0 to infinity. If we integrate, and the result is this. And in the bottom we have magnitude spectrum of this signal and the phase spectrum. Let's try to solve it in the MATLAB. So first of all we need to define the symbolic variable, and let's first ms. We just define t omega capital T n this. After that I'm going to define the equation, the integral int for the integral, my input x of t, that is equal to minus t by 2, and multiply by exp minus j into omega into t. And we need to integrate it with respect to the time, and the limits is 0 or 0 comma I n 0 comma I n f infinity. So that is basically our equation, x of t, and that is the basis function of Fourier transform. And with the t is basically we need to integrate with respect to time, and that is the limits. And after pressing the int, so that is our solution, pretty f. And now I want to calculate the value of omega. If this f underscore sub substitute the value of omega from minus pi to pi to calculate the values. Now I have these values. After calculating these values, now I want to plot. So for this we need subplot magnitude subplot 2,1,1 plot abs means I'm going to plot the magnitude spectrum, and here we have delta, that is basically our graph. So if I want to plot the phase spectrum, again plot a double angle and sorry, and that is basically our phase spectrum. So that is our first example. Now go back to the slide. Now now we are going to solve a second example. In this example, we have a rectangle pulse that is defined that is equal to 1 from -t to t, and that is basically the magnitude spectrum. So again, we try to solve it with the MATLAB CLC and again F. And now in this case, we have x of t is equal to 1 omega t from minus capital T to T, and if press the exp, yes, sorry. So that is the solution. Pretty F, we have this form, and now I substitute sub F underscore S sub this time I just put value of capital T. Let's suppose I put it 0.5 second. So easy plot sub. So we have a graph in this diagram. Let me plot again. So that is basically our magnitude spectrum. As if easy plot F minus pi to pretty that is. So that is a magnitude plot. If I plot it for so and this is also depend on the time capital T. So that is our graph. So this is the magnitude graph of square pulse, rectangular pulse. And now go back to the third example. Third example is basically inverse Fourier transform. In this example, we have again a square spectrum. Spectrum is given of a signal that is from minus omega to omega square. The magnitude of this every frequency component is under root 2. Now I'm going to calculate its inverse Fourier transform. So go back to the MATLAB. In this case, just need to define F is basically SQRT square root of 2 For the inverse Fourier transform, we have j omega t integrate with respect to omega minus omega to omega, and last thing, we just need to multiply with 1 over 2 into pi. So okay, bracket 1 bracket is missing. Yes, so pretty f, so that is our solution, inverse Fourier transform in this case. So let's put the value of f underscore sub. Now we need to put the value of omega, that is equal to, let's suppose 0.5 into pi. The easy plot. F underscore UBs. So again we have this tab. We know the square pulse is basically the spectrum. Inverse Fourier transform square pulse is again this sig function. So that is basically how we calculate the inverse Fourier transform in MATLAB. Procedure is very simple. You just need to write the equation. If you know the trick to write the equation in MATLAB, so it is very easy and useful for you. Hope you people like my video. Kindly share, subscribe my channel, and like me. If you have any query, you can ask me question in my comment box. See you. Allah Hafiz.